Okay, this is concept number 3, which is starting into exponent rules. So we have a few different rules that we're going to cover in these notes. The first one is product of powers property. So if you're multiplying powers that have the same base, the trick is to add the exponents. What is extremely important is that they have to have the same base as one another. So if we look at the example down below, we have 5 to the 6th power times 5 to the 3rd power. Whenever you're setting these up, the bottom number is your base, the top is your exponent. So what's important is that these two pieces that you are multiplying together have the same base, okay, which these do. These both have a base of 5. So if I am multiplying two things together with the same base, the shortcut is to just add their exponents. So I'm going to keep my base exactly the same. It stays a 5. And then I'm going to add the exponents together. So I have a 6 and a 3, which means it's going to give me a 5 to the power of 9. So the base stays exactly the same. I'm not changing that 5. All that I'm doing is adding the exponents together. So one important piece that tends to be a big mistake here is that you do not multiply the bases. The base stays exactly the same. It stays a 5 in this case. The only thing you're changing is the exponent of it. Okay, so we're going to look through a set of examples. So our first example is 3 to the 2nd power times 3 to the 7th power. So again, their bases are the same. They are both a 3 raised to an exponent. So that's the same thing as taking the 3 and adding the exponents. So it stays a 3, and my new exponent is the 9th. So it's a 3 to the 9th power. Okay, again, the base stays the same. All you're doing is adding the exponents. Now, in this next example, again, we have a base of a 5. Be really careful here. Even though you don't see it, this first 5 actually has an exponent of a 1. Okay? If you don't see an exponent, that means the exponent is 1. Which means if I'm multiplying these together, they have the same base. So it stays a 5, and I simply add those exponents. So I really here have 5 to the 10th power. Now, third example. Same thing. This looks a little bit different because we're dealing with a negative number for the base, but that doesn't change anything. The entire base is the negative 7. So in my answer, my entire base is still the negative 7, and I'm adding my exponent. So this negative 7 really has an exponent of a 1. So I'm adding my exponents of a 2 and a 1, which means my final answer is negative 7, still in parentheses, exactly the same way it was written originally. And I am raising that to the 3rd power. Last example here with this one. Now we have 3 of them being multiplied together. Doesn't matter, it doesn't change the process. They all have the same base, so I'm allowed to multiply them together. So I have an x to the 2nd power, x to the 6th, times technically an x to the 1st. So I'm going to add all of them together. So I have an x is still my base. 2 plus 6 plus 1 is an exponent of 9. So my final answer is x to the 9th power. What's extremely important is that they have the same base. They are all an x, so I'm able to actually multiply them together, and the shortcut is to just add their exponents, leave the base the same. Okay, now, second property is called power of a power. So that means that you have a base with an exponent, and it's raised to an extra exponent. So in this case, the shortcut is to multiply the exponents together. Right? Again, your base stays the same. We're just changing the exponents here. So when I have a power raised to another power, okay, so basically a double set of exponents. The shortcut is to leave the base the same and multiply the exponent. So in this case, I have 3 is my base. Originally, it's being raised to the 4th power. Then that entire piece is now being raised to the 2nd power. So the shortcut is my base stays the same, and I multiply those 2 powers together. So this becomes 3 to the 8th power. Now, let's talk about why we multiply those together. Why does that work? Well, we have to go back to our previous examples that we were just working on. Remember that if this is 3 to the 4th power and it's being raised to the 2nd power, remember that exponents are telling you how many of something you have. So if this is telling me that I have 2 of these 3 to the 4ths, so that means I have 3 to the 4th times another 3 to the 4th. So now this is the same as our last property. I was multiplying something together that had the same base. So the base stayed the same, and the shortcut there was to add the exponent. So it's 3 to the 8th power, which is the same exact answer that we got originally. So this is just the work to show why we can multiply the exponents. Right? Remember, an exponent is showing you how many of something that you have. So since this 3 to the 4th power is being raised to the 2nd power, that means I have 2 of these. So 3 to the 4th times another 3 to the 4th, I can just add those exponents together. Right? So let's look at a few examples of that. First example, so I have 2 to the 5th power is being raised to the 3rd power. So my base stays a 2, and I can multiply those exponents together. So it's the same as 2 to the 15th power. Same thing with this next one, and it looks a little bit different because of those brackets. It's only because that 6 is negative, so we had to have parentheses around the -6. So now my base is still a -6 in parentheses, and I'm going to multiply my exponent. So 2 times 5 gives us to the 10th power. Third example, x squared to the 4th power. It doesn't matter that this is a variable instead of a number. The process is still the same. My base stays in x like it was, and I multiply my exponents together. So 2 times 4 just gives me x to the 8th power. Now, fourth example, and again, this looks more complicated, but it's not. It's the exact same process. Our base is just something bigger here. Our base is the entire y plus 2. So now my base stays a y plus 2, and I'm going to write it exactly how it was, so I'm going to keep it in parentheses. But now I can multiply these 2 powers together. So it's still y plus 2 to the 12th power. So it doesn't change the process. Just because the base looks a little bit different, the process is still the same. We were still raising an exponent to another exponent. So you have to multiply them. Okay, last property is power of a product property. Right? So to find the power of a product, find the power of each factor and multiply. So this is just increasing what's going on as your base. Okay? The process, again, doesn't change much from the previous examples, but now we're increasing the size of our base. We have multiple pieces connected in our base. So in this case, I have an x to the 3rd power and a y to the 2nd as my base. But they are all being raised to this 4th power. So it's kind of like distributing. This 4th power has to get connected to that x to the 3rd, and it has to get connected to the y to the 2nd, because they're both part of my base. So it's really, the work for it is x to the 3rd power times 4, because again, it's a power being raised to another power, so the shortcut there is to multiply. And it's the y to the 2nd power times that 4th power. So it's basically distributing that exponent to each of your bases. So this becomes x to the 12th power, y to the 8th power. And this is all just one answer. Okay, there's no symbol between here. These are technically being multiplied together. So it's really x to the 12th times y to the 8th. There's nothing else I can do with that because those bases are not the same. So you cannot add the exponents here. The bases are not the same. So that is your final answer. So let's go through some examples that are similar to that. I have 24 times 13 in parentheses, and that's being raised to the 8th power. Now, we're dealing with exponents, so we're going to practice the property where we are just basically distributing that exponent into each of these. So this is truly 24 to the 8th power times, so I keep this in original symbol between, times our 13 also to the 8th power. Right? Now, yes, we could figure out what that final answer is. It's not what it's asking for here. It's just practicing using these skills with the exponent. Right? So I could finish this and multiply and get one single answer, but that's not what it's looking for here. Second example, I have a bigger base. I have 3 pieces to my base. So I have a 9, I have an x, and I have a y in my base. So this exponent of a 2 technically needs connected to all 3 of them. So the 9 gets a squared attached to it. The x was really an x to the 1st power, so when I multiply there, it just gives me an x to the 2nd power. The y was a y to the 1st power, so when I multiply there, it just becomes a y to the 2nd power. Now, I can simplify that. 9 squared is really 81. Remember, that's 9 times 9. Gives me an 81, and then my variables stay exactly the same, x squared, y squared. Next example, -4 times z to the 3rd. So again, this 2 gets attached to both. So I have a -4 that is being raised to the 2nd power, and a z to the 3rd that's being raised to the 2nd power, so I'm going to multiply that. -4 squared, remember, is -4 times another -4, so it's a positive 16, and then we get a z to the 6th power. Last couple examples. Now here, this negative is on the outside, so it is not included in what's being raised to the 2nd power. So that negative is just going to carry along through the answer. So I have a negative out front. This 4 is being raised to the 2nd power. This x to the 3rd is being raised to the 2nd power, so I multiply. Negative stays out front. 4 squared becomes 16, and that becomes x to the 6th power. So in this case, because that negative is out front, my final answer is negative. Then, final one here. This is much larger, but it's the same process. Every one of these bases gets this exponent of a 3 attached to it. So I end up with a 2 to the 3rd power. Then my x to the 4th gets that 3 attached to it, so they're being multiplied. My y to the 1st gets that 3 attached to it. And then my z to the 3rd also gets that 3 attached to it. So this 3 gets attached to every piece of your base. And then you just simplify. So 2 to the 3rd power is going to give you 8. You're going to get x to the 12th, y to the 3rd, and then z to the 9th. Now, these last examples are combining all of those skills together. So you have to use all of the different pieces of it, right? So in the first one, you're going to multiply the exponents first. Then you have to add the exponents at the end. Okay, so I'm just going to go through and put the work in here for these.